This is an introduction to the math lessons, which accompany the physics and chemistry courses. There will be one math lesson for each science lesson. Many middle and high school students struggle with chemistry and physics. We believe that a lot of that has to do with math, specifically a few concepts that really need to be fully understood in order for students to grasp the higher level chemistry and physics concepts. Now in science, math is used primarily for measurement. This is what sets science apart from all of those philosophies such as alchemy that came before it. So measurement is key to making something scientific. And the math is critical for us to keep precise measurements and then be able to calculate and analyze those measurements. Some measurements that you're probably familiar with include distance, volume, time, and mass. Now, all measurements need units to tell us what they mean, and sometimes those units can be relatively simple, but sometimes they're fairly complex. Units for mass include grams, kilograms, and milligrams. Units for time could be seconds, minutes, years, or milliseconds, depending on how long the event that you're measuring will take. Some units for volume are liters and milliliters, and another one, cubic meters. In fact, you can take any unit for distance and turn it into a unit for volume by cubing it. Here you see someone measuring the width of a piece of wood. They're using the units of centimeters. Now, what if you wanted to measure something a lot smaller? Then it would be more useful to use millimeters, which are 1/10 of a centimeter. Or something the size of a building or a field would be appropriate to measure with meters. And then, of course, to measure greater distances, you'd probably want to use kilometers. So you all know that measurements need units, and the units will depend on what you're measuring. Sometimes units are fairly simple, but other times they're very complex, combining two or more other units to create a new one. Take a look at speed. Notice the units within units as we talk about how a cheetah can run 25 meters per second or 90 kilometers per hour. In both these cases, you'll notice a unit of distance per a unit of time. Power gets a little more abstract. A light bulb could dissipate 60 watts of power. What's a watt? A watt is a joule per second. So a light bulb dissipates 60 joules per second of power. What is a joule? A joule is a unit of work or energy. So that means that power comes in units of energy per time. Another interesting measure is density, or how much something weighs compared to how big it is. Here we have a surfboard, and its density is 30 kilograms per meter cubed. Now the density of water is 1,000 kilograms per meter cubed. So clearly the surfboard is much less dense than the water and will float. And you'll notice that the units of density are a mass unit divided by a volume unit. Our last measurement example is pressure. Here you see me pushing down on a pencil eraser. I'm exerting 4 newtons per centimeter squared of pressure. So you'll notice that the centimeters squared is a unit of area, and the newtons is a unit of force, which we'll talk more about in future lessons. So what happens if I change the area that I'm pushing on? Even though the force is the same, now that I'm pushing on a pin, the pressure suddenly jumps to 5,000 newtons per centimeter squared. Now you'll often use units of pressure such as pascals or atmospheres. And even though those units are just one word, in them is always a force per area, because that's the definition of pressure. Now, you might have gotten the point that many units in science are one unit per another unit, or a ratio. And there are many more examples that follow this pattern. This is why it's so important to understand ratios and really what they mean in order to understand what you're doing in science. In our next lesson, we're going to dive into what is a ratio and what is a proportion. And we're going to look at not just how to change a decimal to a fraction, but how a decimal already is a fraction, and how a percent already is a fraction. We'll also do some manipulation and look at how ratios change, but also stay the same.